If you wait to remove all the risk, you will never ship a product. Well, the fundamentals actually, you got to look at it from two different viewpoints. The first viewpoint is the sources of risk. The second thing is once you identify the risk, how do you get rid of it? The first source of risk is the customer requirements. If you get those wrong, obviously nothing else matters. So there's actually a tool called Requirement Risk Assessment. That is a company we created. The biggest thing we found out is most companies spend a lot of money designing products without ever asking what the customer wants. And in the end, when it doesn't meet what they want, they're surprised. The second source of risk is design requirements. The customer does not speak to you in a language you can design to. Also part of the Requirement Risk Assessment is the translation of the customer requirement into a language that our designers can design to. So in the case of a transmission, we might say, hey, the transmission has to last for 10 years. But if you look at the actual design requirement, you will identify the number and types of shifts over the 10-year period and the types of conditions, because the designer can now design to that. So again, that's part of the requirements risk assessment, and that leads to what we call design validation. Now, the design validation plan will actually have two steps. What we'll do first is we'll do a validation to make sure the right requirements. Well, then we'll go design the product, and when we come back, we'll revalidate it using the same thing, but now perhaps with physical testing to prove we meet the customer requirements. The next source of risk is it's not manufactured to spec. The design FEMA is the risk management tool we'll use to assess the adequacy of the specs in the code and meeting the design requirements. The design verification plan is the QMS tool we'll use to actually determine the risk, and that's actually how we set the probability in the design FEMA. One of the common misconceptions of doing design FEMA is that people will set the occurrence numbers right in the middle of the design FEMA session, and I'll look at them and I go, how did you do that? You haven't done any design verification yet. And they'll tell me, oh, that's our historical values, and I will tell them, I go, this isn't a risk assessment on the one you did last year. This is a risk assessment on this particular product. And the final source of risk is you can do all that right, and if the customer doesn't use it as intended or maintain it as intended, your product's going to fail. And the tool we use is what we call a usage risk assessment. Some people call it a process FEMA on the use of the product. Other people call it an application FEMA. But the bottom line, what we're trying to do is anticipate every possible user misuse and make sure either we have the elements in our design to react to it or we've provided adequate instructions. You must first begin by defining what we call an objectionable incident. So in the case of a customer requirement, an objectionable incident would be you get the wrong requirement. In the case of a design mistake or a design, that would be like a design failure. In the case of manufacturing, that would be producing a product out of spec. Once I identify what the objectionable incident is, the next step is to define the harm and the severity of harm. So we basically have to ask, when this objectionable incident happens, what's the potential impact? And actually risk is the combination of those two. Basically, what's the severity of harm and how often am I going to be exposed to it? So if I want to get rid of it, the next thing I have to ask is, where does it come from? What are the root causes? And depending on where you're at in the development process, those root causes will take on different forms. I then ask myself, what controls do I already have in place? You know, there's going to be controls to prevent the source of the risk. There's also going to be controls to mitigate a risk. As an example, if you're working on a process FEMA, and one of the sources of the risk is an improper adjustment, the control would be an instruction on how to adjust. A mitigation control would be an inspection for the defect. So we can't stop the objectionable incident, but we try to contain it, keep it from getting it to the customer, and maybe change it from an injury to a scrap product. Once we get those done, the next thing you have to identify is, what is that probability? And like as an example, in the case of a design FEMA, you would do design verification to assess the adequacy of the specs. So now that I know how often the incident happens, I know the severity of harm, and the bottom line is, no matter what business you're in, you have more sources of risk than you have money to deal with. You now basically have to prioritize them. And so you prioritize them, you try to put your resources to the best place to reduce the risk the most. And the last thing is as you make changes, you have to keep track of them. One of the misconceptions is all risk can be removed, okay? There's no such thing as a set of perfect customer requirements. There's no such thing as a set of perfect design requirements or the perfect design or the perfect process. If you wait to remove all the risk, you will never ship a product. So bottom line is you're not going to remove all the risk. The second, number two, which is almost equal to number one, is that you can manage risk without getting to the root cause. I would say I reviewed hundreds of FEMAs over the past 30 years. I would say probably 98% of them don't get to the root cause. Oftentimes, as a cause, they define another failure. So they'll say, we didn't work. Why didn't we work? Because we broke. Well, in a design, the risk is caused by specs. So if you don't drive to a spec, you're not going to make the risk go away. So I would say those are the two biggest issues. People believe they can get rid of all the risk, and they believe they can manage risk without getting to the root cause. The key thing I want everybody to understand is it doesn't matter what you're doing. In one week, I worked on spinal implants, fly fishing reels that the pros use, and compound bows they use in the Olympics. And I used the same method for all three companies.